Welcome back to Software Architecture Vlog series, where we speak about all things software architecture. I'm your host Tengiz. I'm a software architect with experience in application, solution, and enterprise architecture fields, and I'm also a book author. My book is about engineering excellence, software architecture, leadership best practices, and many other great things in the enterprise world. Tell me you have not heard this yet. Today I want to discuss an advanced level software development process. In other words, I will answer a question: how to become a pro. A little background to this video: I have a blog post on my website which I called Software Development Strengths Scale, and there I have listed all these skills that I'm going to mention in this conversation. But there they allow you to measure your strengths. In other words, you pick those skills which you practice on a daily basis while developing software, and you will see where you land on the scale from 0 to 100% strength. So you can think of this video as an explanation to those skills. There are a total of 24 skills, so I will have to be quick in this video. I will have to time box each topic and each skill and speak a little bit faster than usual, so that we can fit the entire topic in this video. And another interesting note: everything I'm going to describe in this video, I've been doing it myself, hands-on, and this is absolutely realistic. You just need to give it a try. So let's start with basic stuff. These are the things that most of the software engineers do nowadays, and that is why we call them software engineers. The technique number 1: upfront brainstorming mentally or verbally. In other words, before you start coding, you need to think about it a little bit. If you don't do that, your code will have to be rewritten in many times, and that is a waste of time. So always think before writing code. Technique number 2: upfront brainstorming using physical whiteboards or papers. In other words, besides just thinking or talking about this, you need to just draw it out. Visual element of verification helps a lot. Technique number 3: write unit tests after you write code. This is the worst case scenario. If you cannot write unit tests before the code, write them at least after. Where unit tests help is if the code behavior changes in the future and somebody breaks accidentally the intended behaviors that you put in place today, then the broken unit test will notify them about the adverse effects, and they will have to decide what to do. So in a way, unit test is a message to the future, to yourself or to other developer who is unintentionally breaking the code behavior. Technique number 4: write human-readable and clean code. Do you know the difference between a code and a human-readable code? Any code can be read by a computer, but not any code can be digested by a human brain. Suppose you have two code blocks which do about the same thing, but understanding and digesting one of them takes you twice longer than the other, then guess which code block wins in this category? Technique number 5: peer code reviews. These are the code reviews, which we sometimes call PR or pull request code reviews, or just the principle of 4 eyes. You want to ensure that you didn't miss something, so usually when somebody else, by having an objective view at the code, looks at your code, can notice those glitches which you might have missed accidentally. Technique number 6: following OOP and OOD principles. Object-oriented programming, object-oriented development. This is the technique which tells you that you should not write procedural code. Do you know the difference between procedural and object-oriented code? Well, one example of the difference would be to maintain the state and encapsulate it within the objects instead of just passing it around through the methods. Most of the developers who use even object-oriented programming languages such as C#, for instance, write procedural code, but they think they write object-oriented code just because the programming language is object-oriented, but that's not true. Technique number 7: learn and follow design patterns, at least gang of 4 design patterns. This is a group of patterns which teach you how to put together different classes and interfaces to achieve certain behavior. Design patterns help you optimize not only how you structure the code, but also how others read and understand your code, because they, in a way, act like a shared vocabulary between you and other professional developers. Technique number 8: follow and learn solid design principles. And solid is an abbreviation for 5 principles. starts with single responsibility, ends with dependency inversion. And these 5 patterns remind you about core 5 principles that you can easily learn and apply to your code, even if you don't know much about design patterns. Now, do you do all these techniques? You can be honest, not everybody does it, but we still call them developers. But in my opinion, to be at least a mid-level developer, you need to master all these techniques and apply them to your daily work. Now remember, these were just basics, so let's move on to the advanced part. Advanced technique number 1, let's go back to the upfront design and brainstorming. And in this case, if you want to do it in the advanced fashion, you need to use some kind of accepted and well-known design paradigm such as UML, for instance. In other words, you need to create diagrams because they will survive time. If you use a whiteboard or a paper, you might throw them away or clean, and then the brainstorming results go away. But the UML and the diagrams stay for a longer time, and that's why this is a more advanced approach. Advanced technique number 2, choose technology under architecture and not the other way around. A lot of software architects and software developers start with the technologies. They see some cool technology, for instance, they learn about microservices or APIs, and they want to turn everything into microservices and APIs, and they incur sometimes an unnecessary distribution overhead, which is not necessary. So you need to understand first, you need to know what the problem is that you're solving, and then you need to choose the right technology using which you will achieve that problem's solution. In this case, technology can refer to both the design patterns such as microservices, as I mentioned, or some specific technologies, for instance, AWS Glue. Advanced technique number 3, write unit tests not only for the backend, which is much easier, but for the front end as well. A lot of engineers do not realize that you can write unit tests for the front end as well using JavaScript unit testing tools such as Jasmine, for instance, and the Karma runner if you are using Angular in this case. So your unit test must cover everything you write on both the backend and the front end. You should have full coverage. Technique number 4, write unit tests before you write code. Earlier I said you need to write unit tests at least after the code, but if you write them before, you gain much more advantages. First, you gain all the advantages of the regular unit test, which I mentioned earlier, but ahead of time writing unit tests gives you an advantage that you don't have to run the application so many times to debug, because the unit tests written ahead of code help you write the minimal code that passes those unit tests, and that's it, your code is ready. So TDD is much faster than unit testing, and by the way, I have an article on that topic as well. You can go check it out and find more proofs on this subject. Technique number 5, write automated acceptance tests. No, this is not for testers, this is for engineers. Acceptance tests are those which you can implement using integration tests or some other techniques, for instance, behavior-driven development, and those tests are written by developers. So if you are a developer, you can learn this technique. You can write acceptance tests in your programming language. Technique number 6, taking acceptance tests to the next level, write them ahead of code. In other words, for instance, if you are practicing behavior-driven development, you would write BDD tests, such as acceptance tests, ahead of time, and then you would write the code which would pass those acceptance tests. Can you do that? Technique number 7, introduce and follow ubiquitous language in your code and in your conversations. Not everybody knows what ubiquitous language is, let alone practicing or introducing it. So just to quickly explain, this is just a unified vocabulary which you and the domain experts would use in the team so that your code follows this singular language. And when the business experts speak about certain topic, your code mimics that language. And when you discuss the code, business and domain experts understand you better. So this technique in a way works like a bridge between the technical and non-technical people. Did you think they are not supposed to understand each other? Technique number 8, learn how to monitor code maintainability using code analysis tools. For instance, there is built-in toolset in Visual Studio which tells you such things about your code as cyclomatic complexity, too long methods or too many functions within a class, or too many parameters within a method signature, and so on. So this helps you see the warning signs which make the code less maintainable or harder to understand by other developers. So you need to check out these tools. Technique number 9, taking the previous item to the next level and taking concrete actions based on them. In other words, refactoring your code when necessary. It can be based on those static code analysis as well as tech debt, which you notice over the time as you develop your software. So you need to take systematic continuous refactoring approach over your code. Yes, I know a lot of developers think that their code is timeless and it will live forever, but that's not the case. Technique number 10, this might surprise you, self-code review before asking others to code review your code. Yeah, why do you think you receive so many code review comments and feedback from others? Because they are the first people who look at your code before you even looking at it again. So glance through your code, look into your own PR before sending it to others for code review. You will notice a lot of glitches yourself and start fixing them yourself. After that, when you send your code to others for the code review, you will receive much less feedback and you will look much better. Technique number 11, pair programming. Yes, you like to write code alone in isolation, but if you do it with others, guess what happens? You both start teaching each other and reviewing each other's code right in the process. So pair programming is a great technique to try. And keep it fun, of course. Don't take it to the extreme. Don't do it 24 hours. Just do it when it's proper to do so for both sides of the pair programming. Technique number 12, learn and follow patterns of enterprise application architecture. This is a great topic. This is a great next level or the next staircase step for the developers who want to advance their careers to become architects. This is about application architecture patterns, and the example of those patterns would be, for instance, repository, which is not covered in the Gang of 4 patterns. For instance, Facade belongs to Gang of 4 pattern group. Technique number 13, learn and follow the 12-factor app principles. These are great 12 principles which can help you build great quality applications which run in the distributed environment seamlessly. Example of one principle from the 12-factor app principles would be to make your services stateless. That's a grand principle, for instance, right? And the number 14 and the final advanced principle would be to learn and try to practice domain-driven design. The domain-driven design consists of 2 pieces. First of them is the model-driven design, which is more tactical approach, which is for more engineers. And if you want to advance your skill set, you can look into the second part of the DDD, which is the strategic domain-driven design, which is about bounded context and domains and subdomains. So domain-driven design can be considered as a science that is tailored toward decreasing the complexity in your software and thus increasing the maintainability of the code and helping others faster understand what the code does and bridge the gap between the domain experts. This is a huge benefit to the software, and you get the most points for this on my scale as well. And now let's try to answer the question of the day: how to become a pro? Well, the first obvious solution would be to go and learn a few things about each item that I mentioned in this long list of 22 items. Yeah, I know it takes some time, but once you do this, you are ahead of the game immediately. You are one step above others if you know what each of these items at least means. If your time allows to do so, go and learn each of them in deep detail, and believe me, you will be a pro. And finally, you can consider other ways to learn this content. For instance, find experts who practice these items on a daily basis. Ask them to help you learn. Maybe you can look into the technical training courses. By the way, I have a couple of them on my website. If you or your team are interested, you can come and reach out to me. And finally, you can read my book. Yes, you can think of it as an advertisement if you want, but my book is a great way to learn a lot of advanced techniques faster in the short time frame. Let me reiterate, when I develop software, I follow all these techniques, and so this is absolutely doable. And if you do this, believe me, you will be highly qualified, highly valued professional engineer. So I highly recommend you do this. And that's it for this topic. If this video makes a couple of more pro engineers, this is a huge enough accomplishment for me, so I'll be very grateful. I do want to build a lot of great engineering talent, so help me do that by clicking thumbs up button, by subscribing, leaving your comments below or questions or suggestions. Check out my blog for more great learning material. and my book as well, which I mentioned a couple of times during this video, and this time I will not comment too much except to say that this is a book about engineering excellence, software architecture and leadership best practices in the enterprise world. You were watching Tengiz, your host for the Software Architecture vlog series. Thank you.